Integration, here are a bunch of things. You read it in your spare time. Let me explain it in a very quick way. So I have a big F, I do this, then it gives me small f. And then integration is exactly this. You can think of it as if I call this red arrow differentiation, then I can call this green arrow, you can call it something like this, right? It's like an inverse. And then people don't like this symbol, they just call this symbol. I'm now assuming you don't know what's integration, although I know most of you have learned it in high school. So the starting point, we will call this what? Inverse of differentiation. We will call it antiderivative, okay? I don't spell the full thing. For integration, there are multiple names. For example, antiderivative, inverse derivative, primitive function, primitive integral, indefinite integral. They are all the same thing. And any constant c is 0, that means what? If I plug the c here, it also gives me this f. And this actually links back to what? This guy is not what? Do you remember which one? Surjective or injective? Which one? If I see this as a function, you remember a function, I have a f, input is a set A, output is a set B, this is called domain, this is called total domain, and they are three things, injective, surjective, and if they are same at the same time, we call it bijective. Now, if I have this, I can see this as a set A, I add a C, that means I have two different X here, give me the same B. So this F, which is dx here, is what? Is not what? Yes, because this is not injective, therefore it's not bijective. And you remember, if we have bijective, what do we have? If a function is a bijective, we have this. And if we see this as a f, as a function, and this is not bijective, right? So this guy may not exist. And this whole thing is not injective. So it's not bijective. That means immediately we have the conclusion that something, the green arrow doesn't work. And because it's not injective, there are multiple things here give you this. So when you go back, you need to talk about all the things here. You cannot talk about just one thing. So definition, if I have a big F, I derivative it, give me small f, the big F have a name called primitive function. Very naturally, we need to ask two questions. Does it exist? And is it unique? I just told you, this guy is not injective, so it's not unique. But does it exist? Later. So here's the thing, it's not unique. I assume I have df is small f, and dg is small f. Subtract them, and then this guy go in, this guy go inside, I get this, and then because of this two part, I have ff, and then it gives me 0. So that means what? D2 primitive function give me 0. They are different 0. That means what? That means there exist two functions. What function? I can call this g just f plus a constant c. This actually have two meanings. Number one, it's not unique. Number two, if you know one particular member in the primitive function, you add c, it gives you other primitive functions. So that means what? This is saying that it's not unique. But at the same time, it also tells you, if you know one of the member, you know all the member, because you just have plus a c. So therefore, what? Everything up to here, we're just saying that, okay, this green arrow is the inverse process of differentiation. So we call this what? Antiderivative. Now, if I say that, I write this symbol, meaning that come back to get the big F, then this whole thing, we call it indefinite integral. At this moment, please do not think that, oh, it's the same, I put this kind of thing here. No, this is called definite integral or Riemann sum. At this moment, we supposed to be don't know what it is, and also, even though if you have learned calculus in high school, you should not say this thing and this thing are the same thing. They are not the same thing. So for this expression, this thing is called integration. Actually, this is summation. You just imagine somebody pull this symbol and then you become this, and then later on become this. And then what? This fx inside, so this part have a name called integrand. So for sum, this is called summand, okay? And then for sum, you don't have a thing here, so it's different. This symbol has a name called differential. C is called integration constant. And here's the important thing. C actually is any number. So C is a what? It's a set. What set? Real number set. So actually, this addition is not singleton plus singleton. It's function plus a set, which is Minkowski sum we talked about previously. Do you remember? Triangle plus this give you something that looks like this. Okay, for Minkowski sum. That means what? That means I have a function here. What is a function? Function is something that looks like this, right? Add C in function means I push it top, or make it down, right? So that means what? This guy is a set of functions. How many of them? The cardinality of R. Cardinality of R is a Jewish letter that I don't know how to pronounce, okay? Which is larger than this the size of the natural number, right? That means what? This guy is not just non-unique. It has infinitely many elements. How many? Even more than the number of integers. So that means this is actually a bunch of functions, not one function. It's a bunch of functions. After we finish about the uniqueness, what about the existence? If this thing is true for anything x inside AB, that means differentiable in this region, then inverse exists. That's it. And this actually is related to fundamental theorem of calculus, which at this moment, I'm assuming you don't know what is this, so this one later. But the idea is, when we can go here is when this guy exists. That means we can d this function. Then we can come back. That's the idea. And then some function cannot find the integral. For example, if x is rational number, you put 1. If x is irrational number, you put 0. This function, we can't even draw this function. This function is just some crazy function. So therefore, you don't know integral. And the following function, they have integral, but you have no way to know what does it look like. For example, actually the integral of this has a special name called area function, and this one is used in statistics. And then this one, again, you cannot find f that differentiate give you this. There exists such f, but we just don't know what does it look like. This kind of thing have antiderivative. That means you can take integral, but you don't know what does it look like. It's exactly the same kind of argument. Why power 5 polynomial cannot have a algebraic formula writing down the solution. This, you know, x is what, mega b, and then this, right? And then there's a theorem called Galois theorem saying that for power 5, you cannot do that. This is the same thing. Now, you don't see this as quadratic function. You see this as f, and then this arrow is a df dx. For some reason, you cannot get the closed form expression like the quadratic function. Okay, this is just for your knowledge. So we basically talk about what is antiderivative. That means we call it indefinite integral and uniqueness and existence. Then here's the important part. Why integration is very difficult? Because if you go to 2.4.1.5, say that if I have a small f, give me this expression, then this thing is called antiderivative. And this definition is true for any f. That means it includes what kind of f? This kind of crazy f. And that's why, for those who learn calculus in high school, you will find that integration is 10 times harder than differentiation. Because in a set notation is that you know a bunch of things, how to go from here to here. Let's say this is the set of things you know how to do, and you get this kind of thing. But it turns out, if you go back, you only know this part. And much bigger space, you don't know how to do this part. So that's the idea. This mapping is not injective here, it's not surjective here, so this is actually a very bad mapping. And then that's why we won't say they are inverse to each other. We just say almost inverse to each other. For example, d this thing, again, I can call this big F, right? D big F is small f. This is like this, but why they are not the same? Because this is real number, right? So this guy is fx, yes, this guy is fx, but you also plus a real number. Are they equal? No. Two things are equal, to remember. This set is a subset of this set, and this set is a subset of this set. But now we can only say that this guy is a subset of this guy, not the other way around. So therefore, they are not equal. They are almost equal only if we don't care about this number. But strictly speaking, we need to care about this number because this is a set. So we cannot say they are equal. And then we have the first theorem. If I have f and g, if I add them up, multiply a number, I can ignore the constant and then do them part by part. Okay. At this moment, I didn't tell you, okay, how do you integrate this? At this moment, I didn't tell you everything here. So at this moment, how do you solve this problem? You are saying, I need to find a big F that d this thing give me this small f. So that means at this moment, we argue everything from differentiation. That's why here, I prove this. I do not prove it using integration. I prove it by differentiation. So I put a d here. I d this thing. Then it means what? This is what? Right? And you remember from derivative, we said that we have some rule, right? This guy, prime, is each of them. I'm using that so that I can distribute this inside. I don't care what does it look like. It is a function for me. So now I have this expression. Then what? Again, I use the property of derivative. So this one can go out, this one can go out. So I have this. Okay? And then what? Now I just go back to use the definition of primitive function. So that's why I can get this. So you see, I proved something on integral, but I'm just proving everything using derivative. Now we are at a moment saying that why this is wrong. So for those who learned it in high school, integral 1 over x dx, the textbook was at log absolute x plus c. Yes, this is correct in high school. This is wrong in university. Why? If I have this function, it also gives me derivative 1 over x. So if I d this thing, it gives me 1 over x for the log part. 3 is a number, gone. If I did this thing, it also gives me 1 over x for the negative part, did this thing, gone. But now you see, these two constants are not the same number, right? So that means what? That means any f, big F, in this form, with two different C1, C2, also give me 1 over x after differentiation. The picture is like this. If you are saying we have this, you are saying these two curves are mirror image of each other. But previously, I just said that what is integration? Integration, oh, I cleaned the picture. Integration, you said that I have this, right? I have a bunch of things. That means what? This is a bunch of functions. It's not one function. So, if you are saying that this red and blue are mirror image of each other, you are ignoring the fact that it's a bunch of functions. And furthermore, nobody said these two bunch of functions have to be mirror image. They can be free. And since antiderivative is defined as a set, so that means integration, if you say that this is 1 over absolute x plus c, this is one particular case of the antiderivative. That means actually you have this. This is a set, and this is one element E. You only have this. You don't have this. Remember how to prove set equality? You have to prove this guy is a subset of this guy, and this guy is a subset of this guy, then you prove them equal. We have this, but no this, so therefore, this is not equal. That's definition of set equality. So therefore, this is not equal. This is not equal. Equal in high school, not equal in university. I can tell you, many people don't know this. Okay.